for use for what we're about to do. So let's go back to page 115 and let's see how we can apply those two derivatives. So the first one is number 19 that we're going to look at. And this is y equals pi over 2 times the sine of theta minus cosine theta. Okay, now, if this had said just y equals pi over 2, that would be equal to 0. But since this is multiplying this out, we simply remove the y of the pi over 2 and just treat this like we would, like I said, 2x cubed, and we just take the 3 over and do that. But we're going to find the derivative then of this by taking the derivative of sine of x, which we know is cosine x. So this leaves us pi over 2 cosine x minus, and then the derivative of cosine x is the negative sine of x. Well, I'm using x, that should be theta, my mistake. I'm just x crazy, because I have so many x's. So, this becomes y, or pi over 2 times cosine theta plus sine theta. And that's our answer. Not too challenging. Very similar to what we did before, only now we got trigonometry parts in it, but the trigonometry aspect of this isn't bad at all. Lucky us. Number 21. We have y equals x squared minus 1/2 cosine x. Well, we're going to take the derivative of this and the derivative of this and put them together. So y prime is equal to 2x. Because the 2 goes down there, and 2 minus 1 is first power, so that's 2x. Minus 1/2, we'll leave the 1/2 alone, it's multiplying cosine x. But we know the derivative of cosine x is negative sine of x. So this becomes 2x plus 1/2 sine of x. That's all there is to that. Number 23. This one is y equals 1 over x minus 3 sine x. So again, this is two separate derivatives. First one here, this is x to the negative 1 power minus 3 sine x. And so if we look at it from that aspect, we move the negative 1 in front of that. So negative 1 times x, and then negative 1 minus 1, is negative 2. That takes care of the non-trigonometric portion of our program. Over here, 3 is multiplying sine x, so it's 3 times whatever we get for this. Well, we know that the derivative of sine of x is negative cosine x. So that's how we're going to set that up. So when the smoke clears, we get negative 1 over x squared. Get rid of the negative exponent. Plus, because negative times a negative is a positive, 3 cosine x. There you have that. Very simple. And finally, we're going to jump over to problem number 51 on page 116. This has the function of x is equal to 6 times the square root of x plus 5 times the cosine of x. Okay, so we got a little manipulation with this right here. We have to rewrite this in exponential form. So the 6x to the 1/2 power plus 5 cosine x. So we multiply, we bring down this 1/2, multiply it by 6, so 1/2 times 6, x to the 1/2 minus 1, which is 2 halves, plus 5 times, and the derivative of cosine is negative sine of x. So this becomes 1/2 of 6, which is 3. X 1/2 minus 2 halves is negative 1/2. And positive times a negative is a negative 5 sine x. And then we'll finish this part of it up because we can't have a negative exponent in the answer. So this becomes 3 over x to the 1/2 minus 5 sine x. Or, if you prefer, write that as a radical, which is fine. And then this is going to give you 3 over the square root of x minus 5 sine of x. And that's all there is to it. So the proving of where we got it from is more difficult than actually doing the problem. I do that because I've told you this in Chem 2 and Physics both. I don't like throwing formulas at people, say, here, memorize it, and not give any context as to where it came from. So, now you've seen it. And trust me, when you go to college, your professors are going to be doing exactly that. In fact, I've got a whole bunch of videos that I looked at about calculus, and that's all those people did. It was just derive, define, prove, blah, 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 constantly. So, get used to it. Your practice problems. Pages 115 and 116, 20, 24, 22 rather, 22, 24, and 52. There you have it. Good luck.